Hi everyone, my name is Justina. I'm a junior in high school and I'm going to be teaching you about the scientific method. So the targeted audience for this virtual curriculum is grades 4th and up. So let's go ahead and jump right in. So first off, the lesson summary. In this lesson, you will be learning about the 6 steps involved in the scientific method. By the end of this lesson, you should have a better understanding about how to conduct a scientific experiment and the importance of following the scientific method. Alright, so I bet some of you are wondering, what is a scientific experiment and why do we even have to follow the scientific method? What's the point of all this? Well, to answer your first question, a scientific experiment is a test where you only change one variable at a time to figure something out about the world. Now the second question we will explore more later in the lesson, but all scientists must follow the scientific method in order for their work to be considered accurate. So I know I probably didn't answer that question completely, but in order for me to tell you about the point of the scientific method, you need to know about the 6 steps. So, what are the 6 methods that make up the scientific method? Well, as a quick run through, the scientific method consists of observations, questions, hypotheses, experiments, analysis, and a conclusion. So now let's dive into each of the parts in greater depth. So starting with step 1, observation. This step is my personal favorite and one that you guys are all probably doing without even knowing. In this step, you'll look around the world and see or observe what is happening. For example, maybe you're eating bananas and you notice that they turn brown after a while. Or you put your ice in a cup and you notice that it melts quickly. All these observations are super important because they will lead us to our next step. Step 2, question. So in this step, you transform what you have observed into a question, like, why does ice melt faster in different types of liquids? So, in order for the question to be scientific or testable, the question must have an independent and dependent variable. An independent variable is the one thing that you are changing in the experiment. For my example, the independent variable could be the type of liquid, pure water or salt water. Now, the dependent variable is what is being measured during the experiment. In this case, I chose to make the dependent variable the time it takes for ice to melt as measured in seconds. For scientific experiments, it is important that your units are part of the metric system, since most countries other than the United States uses the metric system, which allows for the data to be comparable. So once you clarify your independent and dependent variable, you can create a revised scientific question. The one I came up with is, does the type of liquid, pure water or salt water, affect the time it takes for ice to melt as measured in seconds? It is important that your question is clear and easy to follow so that other scientists can replicate it. Now for step 3, the hypothesis. This step involves you making a prediction. So this prediction isn't just some random guess. It's actually an educated estimate based on what you think will happen. It is always in the form of a statement and not a question. So for my question, my hypothesis is that ice will melt faster in salt water than in pure water. But you could have a completely different hypothesis than me, even if we had the same question. So now on to step 4, the experiment. This step is super exciting, but you have to plan it out in order to reduce the amounts of mistakes made. So before you conduct your experiment, make sure to create a detailed list of materials and procedures. This list should be as specific as possible so other scientists can replicate your experiment. When you start your experiment, the most important thing you must remember is that you are being fair. So you must make sure not to change anything except for the independent variable. Everything else that you are keeping the same in the experiment are called constants. In my experiment, the constants could be the temperature of the room, the size of the ice, or the amount of light that the ice cubes are exposed to. When conducting the experiment, you should repeat the trials at least 5 times, but the more the better. That way you can make sure that the results did not happen by accident. So don't forget to have a data table to keep track of your results. Step 5, analysis. In this step, you take all the raw data that you have collected and turn it into something meaningful. Many scientists put their data into graphs to better visualize it. So in this step, you need to analyze trends in your data to see if you can begin to answer your question. In further studies, later on in your education, you might begin to use statistics to mathematically represent your data. So now on to the last step, the conclusion. So in this step, you use your analysis to answer your original question. You refer back to your hypothesis and see whether your data supports or does not support your hypothesis. So it's extremely important that you refrain from using prove or disprove, because you can't conclude that you proved or disproved something from just one experiment. So now to go back to the beginning and answer the question, what is the point of all of this? Well, the scientific method is extremely important in order to make sure that all experiments are fair and reliable. The scientific community is huge, and scientists constantly check each other's work or peer review before proving something. So now, for a quick review, these are the 6 steps to the scientific method: observe, question, hypothesis, experiment, analysis, and conclusion. So now, if you have any questions, this is my email right here, justinajohn74@gmail.com. If you have any questions, feel free to shoot me an email. And you can also use these links that you see on this page for extra practice. And right here are my sources that you can refer to as well. So that's all I have for you guys. I hope you have a better understanding of the scientific method. Thank you so much for listening. Bye.